Welcome back to Neural Intel. Today, we're doing a deep dive straight into the technical side of fine-tuning large language models, specifically using Ollama.
That's right.
We're going to unpack the process, really get into the nuts and bolts, understand why it's technically valuable, and how you actually do it with Ollama, focusing on the mechanics, the benefits.
Exactly. And we've got some great material to work with. We'll be looking at a guide from R. Stern on fine-tuning Ollama models, which is pretty detailed.
Okay.
Plus some practical notes outlining steps and, importantly, limitations. Then there are insights from Reddit users' real-world experiences.
Ah, good. The community angle.
Yeah, and a YouTube transcript that focuses specifically on evaluating these fine-tuned models, technically speaking, within the Ollama setup.
Yeah.
So the goal is to pull out the core technical understanding from all this.
All right, let's kick things off with that R. Stern guide. It starts by defining fine-tuning. So essentially, taking a pre-trained model and just continuing the training on new stuff.
Pretty much. You take a model that's already been trained on a massive data set, and you continue that training process, but now on a smaller, much more specific data set that you provide.
Okay. And technically, why is this approach so useful? What are the advantages?
Well, the R. Stern guide highlights a few key technical upsides. First, targeted knowledge. If you train it on text specific to, say, medical research or legal documents,
Right.
it gets much better at understanding and generating text in that specific domain. Its responses become more accurate, more relevant.
Makes sense.
Second, adaptation. You can actually tweak the model's behavior. Maybe you want it to respond in a certain style or follow specific interaction patterns based on your custom prompts. Fine-tuning lets you do that.
Okay, so customization.
Exactly. And crucially, efficiency. It's generally way less computationally intensive than training a massive model from scratch. You need less data, less processing power. Think of it like tuning an existing car engine rather than designing and building a whole new one.
That's a great analogy. So you leverage the initial huge training effort. Now, the guide and our notes also get into the how-to with Ollama, the technical steps. Can you walk us through those commands?
Sure. It usually starts with Ollama Pull Your Model. That just downloads the base pre-trained model you want to start with onto your local machine.
Standard Ollama stuff.
Right. Then the actual fine-tuning magic happens with the command Ollama. Create fine-tuned model name dash a model file. You give your new model a name, and that dash flag points to something called a model file.
The model file. That sounds important. Almost like the recipe.
Exactly. You could call it the blueprint. The R. Stern guide and our notes both emphasize this. It's basically a text file where you define everything about your custom model.
Like what specifically?
Well, you specify which base model you're building on. You set various parameters, things like temperature, which controls how random or creative the output is. You can add system-level instructions, like telling the model its persona or overall goal. And you define prompt template so the model knows how to structure its understanding of the input you give it. It's really where you configure the technical soul of your fine-tuned LLM within Ollama.
So total control over the model's configuration via this file. Now, the data set. The R. Stern guide stresses its importance. It's not just about throwing loads of data at it, is it?
Not at all. That's a key takeaway. Quality trumps quantity significantly. You need high-quality data that's directly relevant to the task or domain you're targeting.
Makes sense. Garbage in, garbage out, right?
Precisely. And the format matters, too. Usually you need text files with really clear examples, like here's an input prompt and here's the ideal output you want the model to produce.
Prompt response pairs.
Often, yes. And diversity within that data set is also crucial. If you only show it one type of question, it'll only be good at that. Varied examples make the final model more versatile, more robust.
Targeted, clean, diverse data. Got it. Now, resources. Not everyone has a supercomputer rig. R. Stern touches on optimization.
Yeah, this is practical stuff. The guide mentions using server-level GPUs. Obviously, that speeds things up dramatically, both training and getting responses later.
But if you're stuck with, say, just a CPU,
then quantization becomes really interesting. The guide points this out. It's a technique to shrink the model's size, usually by reducing the precision of its internal numbers, its parameters.
does that hurt accuracy much?
You try to minimize the accuracy loss. That's the goal. And techniques like post-training quantization or PTQ are specifically mentioned as being beneficial for making models run more efficiently on CPUs, so it makes things more accessible.
That's good news, making it feasible on less powerful hardware. Our notes also mention setting up the local environment. What's typically involved there?
Right, the prerequisites. You obviously need Ollama installed. That's the core platform.
Yep.
Depending on what you're doing, especially with preparing data or running evaluation scripts, you'll likely need Python. And the PyTorch library often comes up.
Common ML tools.
Exactly. You might also need to grab some code from Git repositories, maybe for specific fine-tuning scripts or datasets. And importantly, the notes remind us. Make sure Ollama is actually running. You use Ollama run model name to load a model and check that your setup is working.
Okay, standard dev setup checks. Now, here's an interesting point from the notes, a potential limitation. It suggests fine-tuning might not be the best way to inject totally new facts, like from internal company documents. Why is that?
Yeah, this is a really important technical distinction. One source we looked at raises this caution flag. Don't rely on fine-tuning to make the model suddenly know all the facts buried in your private document.
Why not? It seems like you're training it on that data.
You are, but fine-tuning primarily adjusts the existing connections, the weights and biases, based on the patterns in the new data. It's more about adapting the model's style or skills to a new domain or task. It doesn't really excel at memorizing and reliably retrieving completely new factual information it wasn't exposed to during pre-training. The source even gave a rough estimate, suggesting you might only get like 30% accuracy for question answering on that kind of newly injected knowledge, when you probably want something closer to 99%.
So it's not a knowledge database insertion tool.
Not primarily, no. For that specific goal, reliably answering questions based on a specific set of documents techniques like retrieval augmented generation or AG are often considered a better technical fit. They explicitly retrieve relevant document snippets first, then have the LLM synthesize an answer based on them.
That's a critical distinction. Fine-tuning refines abilities, Argy injects knowledge. Okay, so if fine-tuning is successful for adapting skills, how do we actually measure that success, technically speaking? The YouTube transcript and notes get into evaluation.
Right, and evaluation is, let's say, non-trivial for LLMs. The YouTube source makes this point well. It's not like a simple classification test where the answer is just right or wrong.
Yeah, judging sentence quality is more subjective.
Exactly. So how do you measure it? The sources highlight 3 common technical approaches for these instruction-tuned models.
Okay, what are they?
First, general knowledge tests and benchmarks. MMLU is a big one, massive multitask language understanding. It throws like 57 different tasks at the model, covering everything from STEM to humanities, gives you a score for general knowledge.
A standardized test for LLMs.
Kind of, yeah. Second, good old human preference comparison. You have actual people look at responses from different models and just pick which one is better based on relevance, coherence, helpfulness, whatever criteria you set.
Subjective but direct.
Right. And third, this one's pretty neat technically. LLM-based evaluation. You use another, usually larger, pre-trained LLM to automatically score the output of your fine-tuned model.
Using an AI to judge another AI. How does that work in practice, the YouTube example?
Yeah, the transcript illustrated this using Llama 3 within Ollama. First, you run your fine-tuned model on a test dataset data it hasn't seen during training and collect its responses. Then, you craft a specific prompt for your evaluator LLM, like Llama 3. This prompt typically includes the original instruction or question, the known correct answer, and the answer your fine-tuned model gave.
And you just ask the evaluator LLM to score it.
Pretty much. You'd prompt it something like, score the model's response from 0 to 100 based on how well it matches the correct answer, considering accuracy and relevance. The transcript even mentioned a specific function, like query model, showing how you'd technically send this prompt to a running Ollama model to get back that score.
Clever. Using a powerful LLM as an automated grader. Did the YouTube example share any actual results from doing this?
It did. They gave an example where, after just one training epoch, one pass through the data, their fine-tuned model said something like, the meal is prepared by the chef, when the target answer was, the meal is cooked by the chef.
Close, but not quite right.
Exactly. But they noted that running more training epochs improved this. It got closer to the target. In another test on a larger set, they mentioned getting around 55% accuracy.
Okay, so room for improvement. What did they suggest for boosting performance?
Standard stuff, mostly. Adjusting hyperparameters, learning rate, batch size, number of epochs. More training data usually helps. They mentioned potentially using the alpaca dataset, which has like 52,000 examples.
Right.
Also experimenting with different ways of formatting the prompts. And if you have the compute power, starting with a larger base model might give you a better foundation.
Makes sense. It's an iterative process. Did they mention anything else, like efficiency?
Yes, they touched on parameter-efficient fine-tuning, PEEF, specifically mentioning techniques like LoRa.
PEF, what's the big idea there?
The core advantage is resource efficiency, instead of retraining all the millions or billions of parameters in the base model.
Which takes huge resources.
Exactly. PEFT methods like LoRa only modify a very small subset of the parameters. LoRa, for example, injects small trainable adapter matrices. This drastically cuts down on computation and memory needed for fine-tuning.
So faster and cheaper tuning.
Potentially, yes. And sometimes it can even lead to better results because you're less likely to mess up the original model's general knowledge by only tweaking specific parts.
Interesting trade-off. Okay, let's switch gears slightly to the community perspective, the Reddit discussions. What are people actually running into out there with Ollama fine-tuning?
Well, you see a lot of folks asking for advice, especially on using their own data, maybe stuff they've scraped from the web.
Yeah, custom data sets seem common.
Definitely. And there are recommendations for tools to help ease the process. Things like Unsloth or Hugging Face Auto Train get mentioned as starting points, especially for newcomers.
Making it more user-friendly.
Trying to, yeah. But people also share the struggles, the overall complexity, just getting everything set up and running correctly. And the classic LLM problem, hallucination. Even fine-tuned models can still make stuff up.
Hallucinations. Still a challenge.
Yep. And lots of discussion around which base models work best for fine-tuning for certain tasks, and of course the hardware needed. It's a very practical, hands-on community trying to figure things out.
Gives you a good sense of the real-world friction points. Okay, finally, let's dive deeper into this parameter-efficient fine-tuning, PEFT, using that RPF survey source. It sounds like this is really important going forward.
Absolutely critical, I'd say. The survey hammers home the point. LLMs are getting huge, billions, even trillions of parameters. Full fine-tuning is becoming just astronomically expensive, computationally, storage-wise.
Unfeasible for many.
Right.
Right.
PEFT is the technical answer. It lets us adapt these giants for specific tasks by only tweaking a tiny percentage of their parameters, maybe just 1 or 2%.
Wow, that's a huge difference.
Massive. The survey lists several PEFT methods besides LoRa. There's adapter tuning, prefix tuning, prompt tuning, bitfit, which only adjusts bias terms, lots of different approaches.
What's the main benefit again?
Dramatically lower computational cost and GPU memory needs. The survey gives a stark example. Fully training something like Ollama 3.1405B could take 40 million GPU hours on top-tier H100s. PFT cuts that down enormously.
And that really democratizes things.
It does, and these PFT techniques aren't just for text anymore. They're being applied in computer vision and even in multimodal models that handle text, images, audio, etc.
Okay, so it's a broad trend. The survey also mentioned chain of thought reasoning. How does that fit in?
Chain of thought, or COKIT, is more of a prompting technique, really. The survey notes that for larger models, you can prompt them to think step by step, showing their reasoning. This often boosts performance on complex tasks requiring logic.
So you use it with a fine-tuned model.
Exactly, especially a larger one. It's a way to elicit better performance, complementary to the fine-tuning itself. The survey also gives a nice overview of the big LLM families out there: GPT, Llama, Claude, Gemini, Mistral, others. It really highlights how fast this space is moving, the sheer variety of base models you could choose to fine-tune.
A rapidly evolving landscape.
For sure. And it touches on multimodal LLMs, MLLMs, and the tech needed to connect different data types, like text and images, within one model.
It's clear there's a lot of technical depth here.
Definitely. And the survey points out there are trade-offs between different PEFT methods. Some might work better for certain tasks or architectures. Evaluating them involves looking at benchmark performance and how many parameters they actually train that efficiency metric.
Well, this has been a fantastic technical deep dive into fine-tuning LLMs with Ollama.
We've gone from the basic definition and why you do it.
Through the practical steps, the commands, the crucial model file, the importance of good data.
Covered the challenges of evaluation, looked at different methods including LLM-based scoring.
And explored the huge significance of parameter-efficient fine-tuning, PEFT, for making this accessible and efficient.
Yeah, it's clear that while fine-tuning is incredibly powerful for customization, it's not trivial. There are real technical considerations around your data, your compute resources, and how you measure success. Absolutely, it's an intricate process. But the rise of PFT techniques like LoRa definitely shows a path towards more manageable, resource-friendly adaptation of these models.
Definitely a trend to watch.
So for you listening, if you're interested in digging deeper, we'd really encourage you to experiment. Try different data sets, play around with Ollama models and those model files. Research the PEFT methods we talked about.
It's a fast-moving field, so staying curious about the technical underpinnings is key.
Couldn't agree more.
And maybe a final technical thought to leave you with. Consider your own specific challenges or bottlenecks. Could fine-tuning an LLM, maybe using PEFT on carefully chosen data, offer a technical edge or a solution you hadn't considered before? It's certainly a space with enormous practical potential.